Hello friends, welcome to VK Lectures. In this lecture we are discussing the radial forms for gradient, divergent and curl. So the radial forms. So radial forms, these are generally applied in the case of central force problems. So central force problems such as uh, gravitational field, electric field or electric force or gravitational force, then hydrogen atom problems, all these comes under the central force problems. So it is applied in central force where there is in which can be represented in polar coordinates, which means it will have the radius as well as the poles. That means, for example, with respect to x, this line, so this is r and this is theta. So r theta is the polar coordinates, r and theta. So any central force problem can be represented by using the radius and theta, because the central force problem deals with the distance between, or they act along the center of two mass or two charges or 2-point particles. Okay, that is why they are called central force problems. Now as we have seen gradient for in general coordinate system, we are going to see for radial vectors or radial form how can we do that, which means why we need this. If our function phi is a function of r, if our phi is a function of r alone, only r, it is not a function of x, y, z, or in spherical polar coordinates we can also write phi as r theta phi, but theta and phi is constant. Okay, in such cases we can write phi as a function of r alone. So our gradient should be limited to finding the gradient of the function with respect to r alone. Okay, so in general coordinate system, we can write the del operator, which is or del operator is equal to q1 cap by h1 dou by dou q1 plus q2 cap by h2 dou by dou q2 plus q3 cap by h3 dou by dou q3. So this is the del operator in generalized coordinate system. And now we can say, since phi is a function of r alone, and let us also write down for phi for spherical polar coordinates. I am just writing here spherical. So this becomes r cap by dou by r cap by 1, because the metric element h1 is 1, dou by dou r plus q2 cap, q2 is phi cap, by h2 is r dou by dou, instead of theta, that is phi, plus r phi, so this is theta cap, and phi cap by r sin theta dou by dou, this is theta. Okay, this is dou by dou phi. Now since we will write del of just r, that means only function of r, so only the first term will remain, so that is r cap by dou r. So in the radial form, the gradient can be written as phi of r is equal to, gradient of r equal to r cap dou r. These two quantities will not be present because our function phi is a function of r alone. It's a function of only r, which means dou theta and dou phi of the phi, the scalar field phi, is 0. So these two terms will become 0. Only the first term, which is with respect to r, remains. Okay, so we can also write the gradient of phi of r is equal to r cap dou r of phi of r. You need not do all these calculations. Now in general, for any function, gradient of f of r, you can write r cap dou r of f of r. Alright, now just a few functions let us take, usually found in numerical problems, that is del r power n. So this is the first one. So del r power n. So gradient of r power n, where r is a field. So that is r cap dou r of r power n is equal to r cap dou r of r power n is n r power n minus 1. Okay, now so first one. Now suppose if this is gradient of r, that's equal to r cap dou r of r. Dou r of r is 1, so that is r cap. So the gradient of the vector r is nothing but the unit vector in the direction of r. So third del r square, and that's equal to r cap dou r of r square. You get r cap into 2r, that means you get 2 times the radius, 2r r cap. And similarly del r power minus 1, or that's equal to r cap dou r of 1 by r. So that's equal to minus 1 by r square into r cap. So dou r of 1 by r is 1 by r square in the direction of r cap. So minus 1 by r square r cap. Now fifth one, this is important. This is where most the time we find gradient of 1 by r square. So r cap dou r of 1 by r square, that's equal to r cap 2 divided by r cube with the minus sign. So 2r cap by r cube. Now this is where 1 by r square, for example, the electric field, we write the electric field E is equal to 1 by 4 pi epsilon, or in air epsilon naught, q divided by r square. So we need the gradient of this electric field, or the related to the potential V is equal to 1 by 4 pi epsilon naught Q divided by R, the electric potential. So E is equal to minus del V. So what you get? That's equal to minus del V, 1 by 4 pi epsilon and Q. So 1 by 4 pi epsilon naught Q into gradient of 1 by R. So that's equal to minus 1 by R square. So what you are going to get is minus and minus, it will become plus. So 1 by 4 pi epsilon naught Q divided by R square. This is nothing but our electric field. This is our electric field. So that is what is the application where our vector or the function f of r is a function of r alone. When it is function of r alone, you can use the gradient in radial forms. And please kindly note that we cannot find the gradient of the electric field, because electric field is a vector quantity. So we can only find divergent or curl of electric field. Either we have to find del dot E, which is equal to the Gauss law in divergent form, and or del cross E. This is the two things that we can find. We cannot find del E because E is an electric field. Okay, so we are so this is not possible. Either we have to find del dot E or del cross E. Okay, so this is electric field in the direction of r cap. So this is a scalar field which is V, that is the scalar potential which is given by 1 by 4 pi epsilon naught Q by R, and here we can find the gradient of the potential which gives us the electric field. Divergence in or of radial forms. Okay, so divergence of a vector, divergence in radial forms of a vector. So we take the divergence of a vector. So in general coordinate system, the divergence is given by, for any vector A, which is equal to A1 Q1 cap plus A2 Q2 cap plus A3 Q3 cap. So A is equal to A1 Q1 cap, A2 Q2 cap and A3 Q3 cap, where A1, A2, A3 are the corresponding components. Okay, so for generalized coordinate system, we can write del dot A, or the divergence of the vector A is given by 1 divided by h1, h2, h3. So it's as follows: dou by dou q1 of A1, after A1 it is h2, h3, plus dou by dou q2, after q2 it is A3, sorry, it's A1, sorry, A2, h3, h1, plus dou by dou q3, A3, h1, h2. So this is the divergence, but we know only the first term will remain because our gradient, or it is in radial form, is a function of r alone. That means A is a function of r alone. Then what you get is in radial form, del dot A, you can write, which is a function of r, is equal to, this term will remain constant, so that is 1 by r square sine theta into dou by dou r of the function f of r, and this term will remain. So h2, what is h1? h1 is 1, h2 is r, and h3 is r sine theta. So h2 h3 means r and r sine theta, so r square sine theta will remain. So dou by dou r of ar means the first term, a1, so ar into r square sine theta. So two terms, you have to differentiate the first term as well as the second term, UV differentiation. So since theta can be taken out, sine theta, which is independent of r, you can bring that outside. So this becomes 1 by r square dou by dou r of r square ar, and if you write ar is equal to some function of r, you can write the divergence of the vector a, or vector a can be written as f of r, because ar is f of r. So f of r into r cap is equal to 1 by r square dou by dou r of r square f of r. So this is another important formula, very useful. Usually found in electromagnetic theory, where we deals with Maxwell's equations. Usually for del dot E and del dot B. Now let us see different formulas. First one starting with the divergent of r power n into n r cap. Okay. R cap. So before doing that, let us write down the formula. The del dot f of r into r cap is equal to 1 by r square dou by dou r of r square f of r. Okay. So substitute, so 1 by r square dou by dou r of r square, and what is the f of r here? It is r power n. So r power n is the f of r. So this becomes 1 by r square dou by dou r of r square into r power n. So that is equal to r power n plus 2. So that's again equal to 1 by r square dou by dou r of r power n plus 2, that is n plus 2 into r power n plus 1. So again this is r power n plus 1 divided by r square, that is r power n minus 1. So n plus 2 into r power n minus 1. So this is the divergent of the function r power n into r cap. Similarly, you can write for del dot r into r cap, that's equal to r power this is del dot r, that is equal to 3, because just substitute here n equal to 1. in this equation, just substitute del dot r to the power 1 r cap. So that will be equal to n plus 1, that is 1 plus 2 into r power n minus 1. So n is 1 minus 1, 0. So that's equal to 3. So del dot r, or del dot r into r cap, is equal to 3. So third one, del dot r square r cap is equal to 4 times the r. Then you have del dot r power minus 1 r, that's equal to 1 divided by r squared. Now fifth one, that's important, del dot r power minus 2 r cap. This is equal to 4 pi into delta cube of r, which means this function del dot r to the power n r cap, n plus 2 into r to the power n minus 1 is valid only when n not equal to 2. N only for n not equal to, sorry, not equal to minus 2. Okay, only when n is not equal to minus 2. When n equal to minus 2, this is the formula. Okay, this is Dirac function. Curl of a radial vector. In general, the vector del cross A is written as 1 by h1, h2, h3 times h1 q1 cap, this h2 q2 cap, h3 q3 cap, dou by dou q1, dou by dou q2, dou by dou q3, and here you have h1 times a1, h2 a2, h3 a3. So this is the curl of the vector A. Now if we need to write the function, the curl of the radial vector, which means the function A is equal to AR, or only here you get. So here what you can get is the other terms, like let us write down that, we will understand then. 1 by this h1, h2, h3 is r square sine theta, h1 r cap, this is r theta cap, r sine theta, phi cap, dou by dou r, dou by dou theta, dou by dou phi, this is AR, this is A theta into, this is r times A theta, this is r sine theta times A phi. Now for a radial vector you do not have this A theta terms and the A phi terms, which is A theta, and there will be no A theta and A phi terms. Okay, so A theta and A phi term is 0, so these two quantities will become 0, which means the radial vector, or the del cross A, will be equal to 0, because the curl of a radial vector. Radial vector means it goes outward normal. Its curl is 0. That is why the this is del cross A. Del cross of E is equal to 0 because E is a radial vector. It is going perpendicular. Okay. Now, from the concept, that is the curl of f of r is any radial vector, is equal to 0. So this is the idea that if del cross f of r, so f of r is a radial vector, so del cross f of r will be equal to 0. Now we also know that del cross the gradient of some function phi is also equal to 0. So here we have the equation 1, this is equation 2, and from these two equations we can write f of r cap is equal to the gradient of some function phi. So f of r can be written as some gradient of some function phi. Now since del cross f of r equal to 0, this concludes that the function f of r into r cap is irrotational, which means it diverges from a point. That is why it does not curl. So it is diverging away from a point. If it was curling around, this is an electric field, this is the magnetic field. If you curl around, that is magnetic field. So this is an example of electric field which diverges. So f of r can be taken as an electric field. So it is irrotational. That means it diverges. Irrotational, diverges. It does not curl. We can also write does not curl. Curl means winding up. Okay. So if we have a function f of r which is irrotational, then so let us write down that in words. For every irrotational conservative field f, there exists a scalar such that f is equal to del phi. Now what is this conservative? Conservative field means the work done. Conservative meaning work done in this field do not depend on the path. Examples of V potential, electrostatic potential, field. Similarly, we also have the gravitational potential, and also in thermodynamics pressure versus volume, PV graph, all are called conservative field, and they are also called point functions. Point functions. This is due to because the work done depends only on the initial and final points in the graph. Initial and the final points. It does not depend on the how you go. You can go from like this or like this, but whichever path you follow, it depends only on the end points. Okay. Question. F is given to be y square minus x square plus y I cap and x into 2y plus 1 j cap. So this is the vector, this is plus. Okay. Now find phi if f is irrotational. So if f is irrotational, what you can write? Del cross f equal to 0, right? So f is already given, so f is equal to del phi. Now you need to find out phi such that f becomes irrotational. Now what is f is equal to del phi means? Del phi is equal to x cap dou by dou x of phi, we don't know, plus y cap dou by dou y of phi plus z cap dou by dou z of phi. So for each term you will get one value of phi, correct? So let us take the first term, dou by dou x of phi. So f can be written as, this is equal to fx, fy, fz, different components of f. So dou by dou x of phi is equal to, so this is with respect to x, so x cap, what is the term? Y square minus x square plus y. Right, so then phi will be equal to integral y square minus x square plus y with respect to x. So that becomes xy square minus x cube by 3 plus xy. So this is the first term fx. Okay, so but phi should not be different, we have to write phi in single term. So now next use the second term, dou by dou y of phi. So dou by dou y of phi is equal to this, let us write 2xy plus x. So 2xy plus x, which implies phi is equal to integral 2xy plus x with respect to y. So 2x y square by 2 plus x xy. So this is 2 to get cancelled. So x square y plus xy. Now with respect to z, dou by dou z of phi is equal to 0, which means phi is equal to constant. I am writing it as constant itself. So I need to add 1, 2, 3 because this is partial derivative. So phi will be equal to sum of this, but I need to remember which is already present there, I need not write. So xy square, this is xy square here in the first term, and xy square is already existing, so I need not write it 2 times. So x y square once minus x cube by 3, minus x cube by 3, no terms, plus xy, but here there is another term, but I wrote only once, that is fine. Another term, there is one constant, plus 1 constant c. So phi is equal to this much. So f is equal to 3x square y square z power 4 I cap, and we need to find phi. So del phi can be written as f. So what is del phi? That's equal to I cap dou by dou x of phi plus j cap dou by dou y of phi plus ij, let us write k dou by dou y of z of phi. Now let us take the first term here, dou by dou x of phi. So dou by dou x of phi is this. So dou by dou x of phi is equal to 3x square y square z power 4. Now which means phi is equal to, integrate this, so that will be equal to 3x cube by 3 y square z power 4. So that's equal to x cube y square z to the power 4. Similarly, dou by dou y of phi is equal to this is the second term, so 2x cube y z power 4. So integrate, which means phi is equal to 2x cube y square by 2 z to the power 4. So that's equal to 2 gets cancelled, x cube y square z to the power 4. Now the third term, dou by dou z of phi is equal to 4x cube y square z cube, which means phi is equal to, integrate this, so 4x cube y square z to the power 4 by 4. So that's equal to x cube y square z to the power 4. So this is the first term, second term, third term, but all these 3 terms are same. So we will write phi is equal to x cube y square z to the power 4 plus some constant c. Here is a question for practice. F is equal to e to the power xy times yi plus xj plus 2e to the power z times k. Find phi such that del cross del phi is equal to 0, which means del phi is irrotational. So if it is irrotational, you can find phi.